In this question, you're given that fx is equal to x square sine 1 by x if x is not equal to 0, 0 if x is equal to 0. Now you're asked to see whether this function is. So check the differentiability of f of x at x is equal to 0. So now, you can go with the first principles or you can go with the standard formula. So first let us try to differentiate this using the standard formula. So this f of x is x square sine 1 by x, both on the right side of 0 and the left side of 0. So f dash of x is equal to, I'll directly use the differentiation formula of this function. So you get, this is x square into sine 1 by x, product function. So x square times the differentiation of sine 1 by x. So sine 1 by x is a composite function. So you get cos 1 by x times 1 by x's differentiation is minus 1 by x square, plus sine 1 by x times differentiation of x square is 2x. So what is f dash at 0? So x square and x square gets cancelled. So f dash of x is equal to minus cos 1 by x plus 2x sine 1 by x. So f dash at 0 is not exactly defined, right? Because if you put 1 by 0, cos 1 by 0 is undefined. So from the formula you see that f dash of 0 is undefined. So if you conclude that f of x is not differentiable at x is equal to 0, because that from the direct formula you don't get any answer, will be wrong. So whenever you get some complications like this on using the direct formula, so go for the first principles. So what is the first principle? F dash of 0 is equal to limit h tends to 0, f of 0 plus h minus f of 0 by h. F of 0 plus h minus f of 0 by h. That is equal to limit h tends to 0. So 0 plus h, whether it is on the right side or on the left side, we have this function. It is x square sine 1 by x minus f of 0 is 0 by, so f of 0 plus h, so we have to put h here, so by h. So you have to put h here, I've put it wrong. So that is equal to limit h tends to 0, h square sine 1 by h and h gets cancelled. So h into sine 1 by h as h tends to 0. So we know that as h tends to 0, 1 by h goes to infinity, but sine 1 by h does not go to any limit. It oscillates between minus 1 and plus 1. So sine 1 by h oscillates between minus 1 and plus 1. So if you multiply it with h, which tends to 0, any finite number into a number which tends to 0 gives you 0 as the answer, whether it is on the right side or on the left side. So what is the meaning of this? From the first principle, you got the differentiation of f of x as 0. So the first principle will be the final answer. The answer that you get from the first principle is always right. So f dash of 0 is equal to 0 is the answer. That is, f is differentiable at x is equal to 0. At all remaining points also this is differentiable, because x square is a differentiable function, sine is a differentiable function, 1 by x is a differentiable function as long as x is not equal to 0. So at all other points, none of these functions have any problem. Hence, f of x is always differentiable is the answer.